Welcome to the DIY Honda Garage channel. The DTC P1297 indicates an issue with the Electric Load Detector ELD circuit in the Honda Civic models from 2011 to 2015. This trouble code signifies that there is low voltage detected in the ELD circuit, which is crucial for monitoring the vehicle's electrical load. The ELD is located typically within the underhood fuse/relay box, where it plays a vital role in managing electrical consumption according to the vehicle's demand. Therefore, a malfunction in this circuit could lead to various electrical performance issues or unexpected behavior in the vehicle's systems. Before starting any troubleshooting steps, ensure to record all freeze data and check onboard snapshots. Following this process is pivotal in isolating the issues accurately and resolving them efficiently. The main component affected by DTC P1297 is the Electric Load Detector, ELD. Its role is to monitor the electrical load in the vehicle, and based on this data, it helps in managing the output from the alternator to ensure optimal performance. The ELD is generally located in the underhood fuse relay box, making it accessible for maintenance and inspection. By monitoring electrical demand, the ELD assists in maintaining efficient power consumption, which is vital for the longevity of the vehicle's electrical systems. If the ELD detects an abnormal voltage reading, it triggers DTC P1297, indicating that further investigation is needed to restore normal operations. There are several possible causes for DTC P1297. A primary reason could be a defective electric load detector, ELD, which might fail to function as intended, resulting in low voltage detection. Another possible cause is wiring issues, such as damaged or shorted wires that may interrupt the voltage supply to the ELD. Additionally, poor connections or loose terminals at critical junctions, including the underhood fuse relay box and the engine control module, ECM, can lead to unreliable signals. Each of these scenarios needs to be examined to ascertain the root cause of the low voltage circuit and rectify it appropriately. Symptoms associated with DTC P1297 often manifest as various electrical system malfunctions. Drivers may experience notable warning lights on the dashboard, indicating issues with electrical supply or vehicle performance. Additionally, there might be unexpected behavior from various electronic components, leading to erratic performance. Issues could include dimming lights, erratic instrument panel readings, or even the engine struggling to operate properly under electrical load. Hence, understanding these symptoms is crucial for accurate troubleshooting and repairs to ensure the vehicle functions normally. Verification of the problem is crucial as the first step in troubleshooting DTC P1297. Begin by turning the ignition switch to the on-to position, ensuring that all dashboard lights illuminate, indicating power is reaching the systems. Next, utilize the Honda Diagnostics System, HDS, to check the Electric Load Detector, ELD reading. The HDS will provide real-time data regarding the ELD's current output. If the displayed amperage is 72 amps or more, the issue is confirmed as duplicated, and we can proceed to the next step. Conversely, if it's less than 72 amps, it implies an intermittent fault, and further inspection should focus on identifying poor connections or loose terminals, specifically at the underhood fuse relay box and the ECM. In the second troubleshooting step, the next action is to ascertain the specific failure area. Begin by turning the ignition switch to the lock 0 position, ensuring that no electrical systems are powered. Proceed to disconnect the underhood fuse relay box's 3P connector. This action isolates the ELD circuit and prevents any interference during testing. After disconnection, switch the ignition back to on, and recheck the ELD using the HDS. Again, if the amperage reads at 72A or more, we confirm continued failure, leading us to the next troubleshooting step. If it reads below this threshold, replace the ELD and perform repair verification to ensure the system functions correctly. The third troubleshooting step focuses on checking for any possible shorted wires in the ELD line. Begin this step by turning the ignition to the lock 0 position to ensure that the electrical systems are inactive. The HDS is then used to jump the SCS line, which is the security communication system, allowing communication through the diagnostic interface. Following this, disconnect the ECM connector A, 49P, to isolate the ECM from the circuit. Check for continuity between the specified test points. Test point 1 being the ECM connector A, 49P, number 34, ORN, and test point 2, which is the body ground. If there is continuity, it indicates a short in the ELD wire running between the ECM and the underhood fuse relay, necessitating repairs in that section. If there's no continuity detected, then the wiring is intact, and next steps would involve updating the ECM software or substituting with a known good ECM. After executing the necessary repairs, it is critical to verify that the solutions are effective. Start with turning the ignition switch to the lock 0 position, ensuring the vehicle systems are powered off. Reconnect all previously disconnected connectors to restore the electrical paths. Once everything is back in place, turn the ignition to the on 2 position to power the systems again. Utilizing the Honda Diagnostic System, HDS, reset the ECM, thereby removing any logged trouble codes and allowing the system to relearn its operational parameters. After resetting, initiate the idle learn procedure, start the engine, and turn on the headlights to create operational load. Finally, check for any pending or confirmed DTCs. If P1297 still appears, further inspection of connections and terminals is warranted. Preventive maintenance is crucial in ensuring the longevity of the vehicle's electronic systems and preventing DTC P1297 from reoccurring. Regularly check connectors and terminals for signs of corrosion or looseness, which may interrupt the electrical connections. Inspections of wire insulation should also be conducted. This involves looking for any cracks, frays, or other wear that could compromise the integrity of the circuits. Keeping the ECM software updated is equally important, as manufacturers release updates to enhance performance and fix known issues. By carrying out these maintenance routines, vehicle owners can significantly reduce the likelihood of future faults in the ELD circuit and ensure stable electrical performance. In conclusion, successfully handling DTC P1297 involves a deep understanding of the electric load detector's role within the Honda Civic's electrical system. Recognizing the symptoms and possible causes ensures that the technician can approach the troubleshooting process effectively. Each step, from problem verification to repair verification, must be followed systematically, ensuring no details are overlooked. This methodical approach aids in identifying the root cause of the low voltage state and leads to a proper resolution. Ultimately, staying vigilant with preventive maintenance can avoid reoccurrence of this trouble code and keep the vehicle running smoothly, highlighting the importance of routine checks and software updates in modern automotive technology. Please like and subscribe to the channel. See you next time.